Hello, good afternoon from this side. My name is Adu Solomon Adaigufwa. Listen, I don't miss me well. You get plenty people when they ask me, say, "Sure, bro, you no go do something for us again." Some mails have been coming in, a lot of questions, a lot of difficulties in practical sections. People have been calling in and sending mails. I've been helping out to source out data for people's work. I've been helping out all this while. I don't they help people. They take solve their daily problems. So they say, get some of my people when be saying I then new pass, they never get idea of GIS not until this moment when I deal with them. So they don't ask me, say, talk, make I do one small like revision again on top of the whole thing. I say, I know what the video. See, they watch the video, but you see some people, as we talk, this channel are for both illiterate and educated ones. So, waiting you go comprehend, not waiting another person go comprehend. So I say, make I quickly do a brief summary using the term components and the functions of GIS so that they will really get waiting we do waiting we talk about for this GIS. So the components and functions of GIS. So as we talk, we don't already know the definition of GIS. We know say GIS now the way of bringing together, we talked about before from the first class, bringing together hardware, software, data, people, and the method at which you want to use this geographic this geographic reference information. Yes, the way when we say hardware in the sense that computer like our computer and the rest, I know one more could over the talk so that this is a very short summary. We know software like GIS, like S3 software, QGIS, all other GIS softwares. You go put them inside, you go upload them, you go install them inside your hardware, which is you install the software inside your hardware. You go get your data. Of course, we don't discuss various places where you feel source out data from. Then people, you as a person, a very important component of GIS because why? Because say now you will be the person when they use the GIS. So what do you think, what do you want, now you go do garbage in, garbage out. So put what makes sense so that you can get meaningful result. The method and the way at which you take analyze and display these put all these components together. But we'll go explain further gradually. I break them down so that I go feel understand what we mean. Then GIS functions on the other hand, of course, we don't already know say GIS function now to capture, now to store, now to query, now to analyze, now to display and output. Capture now how to gather, store now how to keep, query now how to get specific results like 30,000 population of 30,000 are females. How do we derive the population of 30,000? A population of 30,000, how do we know how many males and females are there? When you just start the query data, you get specific detail. I will explain as we go. The analyze, of course, we know it's analyze, be display and output. So these are the GIS functions and what they really do for us. So when you capture data, of course, as we see customers, you don't know, so okay, you get all your customer details, you know the building. Of course, we don't overlay the buildings, know where all your customers they know the streets where they did, then the reality. Of course, remember just the moderating, these are model reality. So don't forget all those things one don't learn for the past videos. This is not just very brief summary. I don't want to talk too much so that we could just brief and I believe say you know this stage already. So let's explain the functions of GIS. We don't talk of capturing of GIS, capturing data. Here we say GIS must provide method of imputing geographic data. The more input method available, the more versatile the GIS. Now English, make a break them down. What do you mean here? We say to capture data, of course, we must look for a way when we say we capture data. I don't tell that before to capture data. We capture data from satellite, from coordinate system. Coordinate system are those reference number when they tie to ground points. For those when be surveyors, for those when do geography, we not understand on time. And these coordinates when you see here now numbers when we see like digital numbers when they derive a lot from the most centered place in the country or something, So from there they get coordinate system. We'll go deep into all those things with time. Then this from satellite, if you get data from satellite, if you get data from digital data, if you get data from hard copy maps, if you get data from snapping photography, or anywhere you source out your data from, you put infuse all into GIS data. So now all like this when we talk, now the capturing of the data. So on the other hand, we talked about storing of data. I don't explain this one for the first video and the second video before. Say capturing of data. Say storing of data. Now how well you fit store your data. This GIS data one they always they get, they come in two phases. Like say to store data, to come in vector format or in raster format. That is the best way when we say if you take do it. Take put your GIS, put your data into GIS platform in vector or in raster format. Now, the best way if you store your GIS data be that, and the only way when we say if it represent everything when the try model. Vector format, feature class, shapefile, discrete representation of reality. Like this one now, you can say this one from point XY to point XY na road, from point XY to point XY na river, from point XY to point XY, you know. These are a way, if you see this reality picture when they are from here to this place na road, but on the GIS platform, you know, go fit model this reality in the same way on the GIS platform for you to do it and to do analysis. You understand? So it's either you present it in this format, which is vector format, or you present it in a raster format, which is like grid lines when they use represent realities. So I've been done explaining for our previous videos, but as I say earlier, this is just a recapture. This is just waiting, just to make una know, say, I just revision for those when you really catch up. So when we talk about querying data, GIS must provide utilities for finding specific features based on location or attribute value. Of course, this might be the querying of data. Like there, if you see say sectors of Rwanda with population more than 30,000. So if this is not Rwanda map, that means this particular section and that population went past 30,000 people. So for you to get that specific detail from your data, you go query the data. And in doing so, you get result of specific answers to any question when you ask. If you say in Nigeria, how many PDP people actually buy form or vote? If you query this kind of data to get that kind of result, especially in the case of Nigeria, if you query data and say you want to know how many shops or jewelry or grocery shops now they owned by McDonald's, you get that kind of thing. So it's just to query a particular data to identify specific features. So that's what querying is. You understand? So I don't know if you understand what I try to talk. So this is how querying works. Now when you want to get specific answers, if everybody here now boys, you want to know how many boys black and how many they short. So that's how it be. That is how you get derived. That's what we call querying of data to get specific results. Then now on the other hand, we talk about analyzing data. All this is why they mention a GIS function. Mind you, talk about analyzing data. A GIS must be able to answer questions regarding the interaction or spatial relationship between multiple data sets. Just like the example what they give now. You see, when you know they analyze, you don't query the data. Now you won't analyze what you query. You understand? You query a specific something if you want to analyze further. Now, if you see this example when they see a proximity shows you which parcels are within 50 feet of the road. See this reality here now. You want to say, okay, how many donut shops they 50 feet from this main express when they see here? For instance, how many wine shops they 100 meters from this express when they see here? Those when they travel well, if you stop for Kogi, let's assume this is not Kogi State. You don't stop for Kogi Park. Now you can't look for where you go buy gift shop quickly before you reach Warri or reach Onitsha or reach anywhere where you go. You won't go look for how many gift shops they 100 meters so that your boss no go leave you go. You see, this now you don't analyze the data when you get already. You don't already get road data. You don't already get building data. You don't already get shops data. You don't get you go feel analyze the proximity of where you did to where you won't go. Then this now overlay. This already, if you look at this, it is very, 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 very explanatory. already they don't already get this first data shows all where borehole dey. This one when you see na drilling, let's say na borehole. The under one na maybe na river. This other one na maybe na farmland. This other one maybe this one na farmland or soil type. This other one this last one now maybe na buildings, for instance. So when you overlay all this data together, you go see say you fit derive the well type, which is drilling, the building owner, which is Mr. Smith, the soil type, which is sandy. So now when you overlay these data together, now it will give you that sense of completeness of wetin you define. Make I come again. When you overlay data, it will show you that thing when you want analyze. Because why? It dey show you wetin you define. You have to analyze to know wetin you want. You understand? In the real world. Then this now na like network. Network now they show you from one point to another point. They show you short route distance where hospital dey and where accident dey. Accident happen here now. The shortest, closest hospital to this place, to where this thing happen now, and the shortest route to the hospital. GIS, they use analyze those data. If you don't analyze, I no go know. So when they use your Google map, they use your Google Earth, you just see all those designs. It's easy for you. They follow the road. They say take left, take right. Use the first U-turn 2 meters before your destination. All these things now GIS. So now all these background things now they don't do put together. All this data has been put together before they make them visible and usable for you under APIs. When they say they do it and they reach your destination on time. In fact, some of you, of course, Google API, they even show you they show you where there's traffic. So all these things, this is the beginning. It's like the back end of how all these things are being built. You understand? So now so it be when you analyze data. Another function of GIS now to display data. Now how you go come display this data? The final way to display the result of what you define. You can display in map like, you can display in graph like, you can display in a chart, in a pie chart way. You understand? If you see this one now, they show you map. You don't ozone. This one now they show you ozone, orange country, ozone, San Bernardo's, ozone riverside. They show you different countries and their ozone layers. Then now, if you want to represent this same graph for one particular country, let's say state. This now they show Los Angeles, show you all the ozone particles when the air, the atmosphere. So make you see say GIS they even map those things as such as ozone layers, particles in the air, highly concentrated particles or things you cannot see, even smoke, even noise. You know, you can use GIS to map all these things out to know where the problem they come from, for you to do where they call mitigation, you know, so that we prevent the root cause of some of these invisible problems. So if you see this, they show you the highly concentrated, how concentrated the ozone, the NO2, they for the air. This one they show you more of ozone concentrations. So they show you this now map, so you can use it to show, to know how things are and what can be done about it. So displaying data in a very good way, because now it be the way when we say even a layman go fit understand wetin you dey talk about. Now on this GIS sample, of course I use this sample for one of our videos. I don't remember which, I think that the part 1. So this now they show you, if you put all together everything when we don't talk now you don't see say they represent data, this data here in both vector format. If you look at where you go see say these are roads, the lines are bicycle facilities, the one-way lane, you see public school, you see police station, you see bike racks. So you go know where everything they shortcut to follow, where to follow, where not to follow. But if you know they don't embed different layers, road layer, the data of where all the shops data of where all police station dey, data of where public schools dey. They don put all these things together so that you now go fit know where everybody dey, where what is, you know. So now characteristics of GIS. Make I just use this one take round up this revision section. Characteristics of GIS. With GIS software, you can digitally present geographic objective with a variety of shapes and layer those shapes on top of one another to create maps and perform analysis. Now, wetin we know the talk since, you know, you put layers of different data when you put them on top each other so that you fit perform analysis, so that you fit query the data, if you get specific information, so that you fit solve problem, everyday complex problem. You understand? So this one when you see now, this is now polygon. This is not like a state. They show wetin. They show the municipal and census tracts. If you understand what I mean. All these things when they see, so they show you where people gather. They show you, let's say, all this in a population now, where people be this. Now look carefully to the next map, and at the same map at the display. You see? So now to show you, say with GIS, of course, we talk say if you represent geographic objects with a variety of shapes and layers. Those shapes are on top of one another. We talked about before. So now we don't put water layer, lake and river layer on top this one. The normal layer, the first layer, are just the polygon that shows the municipalities and the census tract. This one now we don't come embed on top of her now. We don't come put lakes and rivers. So you don't see, say, you don't know where all rivers and lakes them dey. You don't know, see, say, we don't put the river listen now. The map don't change. You don't know, we say, okay, water dey here, water dey all these places, all these are river. We don't embed river lakes. So these are the characteristics of GIS. Again, we don't put polluting companies. Now, apart from the river, we don't show you, say, all these companies when you see one represent with points are companies when we say they highly pollutants. They are pollutants. Let's say they flare gas, or they flare chemicals, or like a textile company when we say the chemical they use, they take dye and everything. You know, the water, the smell, the fire, the smoke, they burn coal, the miners. You know, now all this indicates where all the pollutant companies them dey. So this now we don't get the data of polluting companies. We don't embed them on top the first polygon again. Now we don't know where water dey. We don't know where companies when they pollutant companies dey. So these are the characteristics of GIS. If you can't lay another layer on top now, which is schools, you feel that? Now you don't see, say, okay, these blue points are where all the schools they located. If, for instance, this map now in Canada or Nigeria or wherever state this is, you don't now see, say, you don't embed water, you don't embed pollutant company, you don't embed schools on top the same data. Now, from this data, when you see now, which solution you fit solve from here? You, when they say you live around this area, you don't know, say, this place, any school when they 100 meters away from this place, no be the school when your children supposed to go, because they are what? They are exposed to this hazard, to any hazard when this company they remit. So you go use your sense, use your brain, get sense, put your pikin for school that is a bit further than where it will affect your children. You never solve one problem. You don't say and say, okay, people, you when they live around this side now, you don't say and say, okay, this water there, you know, if you come put your school picking for here, because one, you know, go feed the cross river every day. That risk is too much. You know, go feed the go turn around, you will spend more on transportation. So they show you how it opens up solutions to everyday problems. Now, I no go get picking, I no go live around here. Get picking, come put them for this school when they here, close to this company. No, because I expose my children to waiting to the hazard when we say they come out from that company. So it no go make sense. So if I live around here, I put my picking for these schools when they here. If I live around here, nothing will make me come put my picking for this. You're there one of these schools. So this is how GIS enable you to add layers upon layers of different data so that it can be easy for you to analyze and do what? And easy for you to analyze and come up with a solution to whatsoever problem there is. Remember, any problem when they see for this life, it get origin. It always get where it is. It always get where it start from. It always get where it be. It always get where it start from somewhere. They always start with location. No matter that problem, now location they start with. The problem of money no dey Naija, abi money no dey your country, abi money no dey your state, abi money no dey your street, abi money no dey your account. Which bank you dey use, where you dey live, money no dey your area, you no fit generate money, you no dey work, not. So it must have to do with location. Location is vital for this business when we do. Location is vital with GIS because with location you go fit know trace origin, the root origin of any problem. So my people, as I said earlier, I just want ring this thing because people don't call me say the functions of GIS, I fuse everything together. They say they enjoy and they like them, but they like small breakdown. Now why I come out with the components and the functions of GIS. So with this one now, I believe say we don't know where all these things they come from. You understand? But now make I just give now explain now further for the buffer analysis why they always tell now. This buffer analysis now, the same thing why I just explained before now. If you know say these companies with red dots, now company when they pollutants, and now you don't embed the water data, you don't embed company with pollutants company data, you don't embed schools data. You won't come ask yourself now, which school now I won't come carry my picking go. You when they live for this area now around these two companies now, you go buffer 100 meters. Buffer means say you go look and say between from the company when get problem 100 meters, any school when they 100 meters from that company, it's no good for your children because any hazard when that company they remit, do it will affect your children. If na air, you give them heart disease or lungs or something respiratory disease. If na water, if na for instance, as I said, if na what company they remit pollute their pollutant na water, let's say like chemicals, you know good. The smell, the even touching your skin, the reaction, good for your children. So when you buffer like that, this circle zone that they see here na buffer analysis. So I don't buffer 100 meters with this one already. Don't say okay if you want put your pikin for school, you no go put them for any school when they 100 meters away from this. If you buffer 200 meters, now you know the one when they save pass for your children. So as I said, I just want to review this. I just do this class for people when they send me mail, they call me, they tell me say they enjoy the class, they enjoy the teachings and everything, but they don't need small briefings. I know, I understand. I know some people don't get geographic background, some people don't get background in GIS from the onset, but they like them and they don't get interest. And I'm so happy for the number of calls that have been coming in. In fact, they sweet my body. Say people there when they follow up, and more people there when they even subscribe to my channel, and they happy. Say they learn something, they get interest. They know say geographers no be people when they finish no be teachers that they end up with. There's more to it, there's more to GIS in fact not be only for geographers now, for any discipline. And I'm happy, I'm really and truly honestly I'm happy to see people call in to thank me, to see people sending mails, to see people commenting on my YouTube channel, and people calling in for their own personal encounters and personal problems, difficulties in some areas. So I put more light to them, some practical sessions. Some other times, practical, boss, practical. I will try do practical sessions for us. So once again, I say make I thank you now. May the good Lord in His infinite mercy continue to bless you now, my people. I love you. I love you all. I thank you now well. My name once again is Alu Solomon Adaigo for Adu. Send me mail, call my number 09033659940. I beg Mukuna help subscribe to my YouTube channel. Just go to YouTube channel, press the red button. It no ad, it no cost you anything to subscribe to my YouTube channel. So I believe with this small one, we don't understand the revision of components and functions of GIS. So good day, have a blessed and fulfilled day, my people. Thank you so much. Bye.